Hello, good evening everyone. Welcome to Krhom Shop Live, where we repair some electronics or die attempting to. We don't actually die attempting to. We try even to respect our health by remembering to turn on the air filtration sometimes. So, what are we doing tonight? Tonight we're doing AIOs. So we have had a few donations to the stream. So we've had two SpeedyBee AIOs from Straylight, who sent them to me. And we have two Newbie Drone AIOs, same ones sent by someone on a watcher of the stream as well. So it's going to be very fun to have a look at those. I have cleaned them up. They had some conformal coating, and these we removed the heatsink last week on those, and they are held together with some silicone glue, which is an absolute pain to remove. So I spent a bit of time removing it. Not everything's I couldn't remove everything, so hopefully it doesn't become annoying, but we'll see what we do with them. Regarding something we left off last time. So last time we spent a while investigating this, which is a Foxier ESC, and we tried a bunch of things, and I said I was going to spend some time looking at the components and at the data sheets. That's not actually the right one. Well, I'll use this as a placeholder for the one we did last week, but that's not the right one. That's actually a Mamba. But what basically I was able to figure out is, oh, that's not good. That's not good. My camera is overheating. I'm gonna have to find a way to put a fan on that thing. Yeah, hot days are coming and cameras are overheating. So I'll turn it off for a bit. We'll do with the camera off and the microscope. We'll do with this camera and the microscope, and I'll find a way to put a fan on it for next time. Is it hot? How hot is it? It's not even that hot. Weird. What happens if we turn it back on? No signal yet. My thing is turning on. Yeah, okay, we got a signal bar. We'll see what happens. So yeah, I found out that the one of the BECs was shorted and was sending VBAT or maybe 6.3 volt from the previous BEC in the chain to the MCUs. So we had a dead driver, we had a dead MCU shorted, and that means I can't really repair it because it's BL32. So if I was to replace it, I can't flash it. So unless I have the exact same ESC where I can put the MCU instead of the broken one, it might work, but I don't. So I could replace it with a generic similar MCU and flash it to AM32, but I don't even know at that point if everything else is going to work. I don't have the BEC to replace it as well, so I kind of gave up and put it in the bin spout. I have a bunch of ESCs already repaired and awaiting repair, so it's fine, good enough to put it in the bin spout and use it to repair something else. And it's dead again. Okay, so we'll have to deal with that later. For now, I'll turn it on when I need to show you something, and for now we'll do with this camera and the microscope, which is the most important part. Yeah, hopefully I'll solve that out for next time. Sorry for the technical difficulties. So yeah, that's about it for what happened in between last time and today. I prepared a few things for a few friends in the meantime, but nothing you haven't seen before. We have a bunch of people already in the chat. We have Spare FPV, hey, Mac Shaky, Biaz, Straylight, Neo, Danza, Spawny, Mads. Hello everyone, welcome to the stream. All right, shall we get into those AIOs? We'll start with the one from Straylight, the SpeedyBee ones. I'll put them in the microscope and we'll do a first visual inspection. Let's do this. So we have this one. I picked one randomly, so yeah, I hope I can distinguish them. Actually, I'll start with the other one because I did notice something while cleaning it up that you might see. I'll try to hold it nicely. So yeah, something. So there's a bunch of leftover glue, but one thing I saw immediately when I cleaned it up is, you can see there's some damage here on the MCU. So those MCUs, I'm pretty sure they're just unpackaged silicon. So it's just a slab of silicon with the design on the bottom and some BGAs, meaning some small solder balls. And you can see that it has a nice cross on it, and I think the corner is missing. And man, that doesn't automatically mean it's broken, but it's not good. So I know from what Straya told me that one of them has a damage or heating an MCU that heats up very quickly. So what I'm going to do is bring in the thermal cam and see how annoying that silicone is to remove. Silicone, sorry, that's silicon and not silicone. It's very annoying to remove. So yeah, I'll have a look at whether this is the one that heats up. If it is, it's going to automatically become a donor, because first, I don't have any donor for that kind of chip. The MCUs with like the BGA MCUs of that format, and also I don't have the tools to redo the balls under it. So I might just pull it off so I can show you the balls under it, the fact that it's a BGA chip. And if we don't scavenge many parts, I can try to get a donor at some point and try to do some BGA repairs, but that means I'm going to have to buy solder balls and a few other things like that. So yeah, it's going to be interesting. But yeah, the chip kind of looks damaged in places. So I'm not very... I'm pretty confident if one of them, the two, is broken at the chip, it's going to be this one. So let's see if you can... Actually, can I... I'll try to see if I can find my fan that I had somewhere to cool down the camera. I have a fan that I set up with some USB-C somethings, and I can try putting it up on, so I can show you actually. I have this fan that I used to use, when we start FPV and people tell you, oh, you need to keep a fan on the VTX so it doesn't overheat. So I use this thing. Nowadays, I use nothing because I just don't mind that the VTX overheats because it's protected. So it just goes into overheat protection and it's all good. But if I can route a cable up to the camera and kind of put this fan somewhere on top of the camera, very rickety solution that will let us, yeah, so there we go. Now there's a fan on the camera. Hopefully it keeps it cool and we can get our camera back. Let's see if I can kind of, yeah, this way it should cool it down. So I can show you where was I at. Yes, thermal camera and checking. Well, first we check whether this this actually gets detected in any way. I'll use my meter actually. Try not to ruin my PC. I'll use this. I need to find this wire. And I'll use this messy thing. Power it up. That way you can see the power draw we get. So as always, for if there's people who haven't seen the stream before, two things. First of all, any question is fair game. Just if you want to make sure I see it, write my name, so at Krhom, and I'll see the questions pop up in orange, so I make sure I don't miss you, but there's usually not so much activity in the chat that I won't see anything. I won't see everything. And secondly, if you feel like you want to ask questions on voice, if you want to interact on voice, you're absolutely welcome to join the Discord. There's a link in the description, and you can join voice. And as long as you don't hold the talk over me or like stop the stream from being from moving forward, you're absolutely welcome to come on chat and ask a few questions or give me advice if it's something you know how to do better than I do. And yeah, feel free to. So let's have a look at the amp draw here, and see what happens. So we get good light. That's nice. We do get a fairly normal, less than a watt draw, so that's pretty good. There's nothing worrying here. Okay. And let's see the other one, the one that's has the broken chip. Well, what I think is a broken chip. We can look at the watts here, see if it goes over 1 watt. Oh yes, 3.5 watts. Yeah, it's gonna be a good thing to check with the thermal cam. Hey Feet, welcome. Hey Taran, hey Dylan, welcome. So let's have a look with the thermal cam, see how cooked it is. What I'm expecting. And you can see in this view how small the MCU is on those boards. So we can't really see it in the microscope, but that's that small chip. It's usually much bigger on other boards, but I mean, AIOs have to be very, very compact. So let's have a look in the thermal card. But yeah, 3 watts, something is shorted somewhere. So I'd like a good way to turn it on and off, but I don't think I do have that. What I can do is try to support this on a box. Let's go with this box. So I can plug it in and let me open this up. Try not to be so rickety. Yes, it's a very long cable, but it will do. That will do, pig. That will do. All right, so we are looking at something here getting very hot. Oh, look at that. It's the MCU. Yeah, MCU is roasted. Let's pull it so I can show you what it is, what it looks like underneath, and see that it's actually, I think we can confirm, and it's indeed a piece of silicon. Let's have fun pulling it. Let's go back to the microscope. So, like I said, I'd like to be able to fix it, but it will require getting a donor, or I can see on AliExpress if I can buy those chips in those MCUs in that format. But I will need, in that case, to buy everything to put the balls back. I'll show you after I pull it out. I'll go for 420, 60% airflow, something like that should be good enough. Let me grab some good tweezers. I'll try those. Are those good? Yeah, those should be good. Chip is so small, I don't want to use a sucker. So here it should take a while to heat up, just because the balls are underneath, so the heat needs to go through the whole chip. I mean, it's not uncommon, even when I desolder FETs, they are kind of under the chip, like I have large parts under the IC, so oh, it's not that thing actually. There we go. So see the thing I was talking about. There's a bunch of solder balls, which I think have had silicone glue stuck on them. And let me show you the chip so you can see how shiny that is. So that's silicon. And it has a bunch of small balls. And you can even see some of the design of the top layer of the chip through it. Let's see how much I can zoom and focus. Let's focus for me first. And focus for you guys. I mean, my microscope is not meant to have super good optical resolution on small things, but you can see some of the design of the chip underneath. So that's pretty cool. It's really nice that basically what happens is when you buy the bigger chips, so the ones from, you know, those regular, do I have a regular? I want to give you a point of comparison. Let me grab the usual. So next to it, I'm going to grab this. You can see it's absolutely broken on the side. It's completely shattered on the side. So this is the normal size. Yeah, so this is the normal size that we deal with usually. And this is the chip that was on this AIO. And what's very likely to be happening is inside this big package, which also has some burn mark here, inside this big package, that's epoxy, like kind of casing, there's probably this exact chip in the inside. So I doubt they make a bunch of different versions of the actual silicon. Maybe they do, but it would be likely that this is exactly what's inside this. And then there's a bunch of wires that run to the legs. So that's, I believe, what is likely to be happening. But yeah, that's pretty much dead. And now we have a donor. Or at least, I want to see what this is actually, if it's like glue or just something else. I see there's a question. I'll come in a second. Let's see if I can. Yeah, there's some silicone glue that actually came under it. So what we'd want to do, even though there was some glue around it, or it's just the glue that piled up, I think. Yeah, you can see the bit of silicone here. But yeah, we'd want to clean that up before we put another thing. And the way you repair those is you have to rebuild the balls on this. That's called reballing. And the way you do that is by cleaning that up with a solder wick. And then either you put a bit of flux and put some balls, like like already ready-made balls of solder, using a mask that lets you drop them in the right locations. Or you get a mask with the holes at the right locations and use solder paste that you scrape on top of the mask, and you put some solder paste on the pads, and then you melt it with solder, with your hot air, and you make some new balls. So yeah, but this one's dead. And yeah, if I grab an iron, oh, that's going to be a big iron. I'm guessing that's probably not going to work very well, just it does, kind of. It doesn't work super well because of the glue. But basically what we want to do is replace, like add some leaded solder and then come with a wick and clean all that up. And I managed to drop a bunch of solder here, which is mixed with the glue. And yeah, glue plus solder. All right, so yeah, we're not going to be doing any of that because I don't have nor the right chip nor the right equipment. So we'll leave it at that. I have a question from Mac Shaky FPV. What do I suggest you do to first get started repairing electronics, ESCs and FCs? You have a nice weather iron, magnifying glass on an arm with LEDs and a few multimeters. I think you do need a microscope. You can get a You can get very good electronic microscopes that are more than enough to do what I do for about $80. I have a link in the description here or on my Discord. I just added a channel with a bunch of links to the things I recommend. But Tomlov DM9 is a very good one you can get for fairly cheap, and you will need hot air. The rest you probably already have. You need some flux, some fine tweezers, and cleaning supplies. It's all quite cheap. It's all in my list, but I think you can't get away from having a microscope and hot air. And bench PSU is very useful, but if you have a charger, there's chances your LiPo charger has a PSU mode, and you can use that. So yeah, so that could be a solution for you as well. Having a bench PSU is definitely helpful, especially one like I have here, and you can see it on the edge of the screen that I can turn on and then off with a button. That's very useful when you just want to be able to turn it off fairly quick. But yeah. Hey, Brandon. Yes, there are. Brandon says, I didn't know they use BGA components. As far as I know, there's only very compact AIOs that use this one, and there's also some of the H7 ones that use BGA. I think I have one in the donors. The secure, I think. Let's check. Thought it was in my donors. Yeah, that's the one. This guy here is, I've seen it in a few boards, the H7 BGA chip. So I'm kind of, for now, I haven't decided to start being able, like trying to do BGA, but at some point I'm probably gonna have to do it. Yeah, Mike Shaky, where you can see online people reballing massive GPUs and CPUs. That's definitely a skill. Like that's not something you can do without some amount of training. It's really not. Yeah, it's quite the effort. All right, so now we're gonna move on to the other one, which, as far as I know, has a damaged ESC. Let's see if we can see it in our inspection. Let's first actually go to screen share. Let's make sure it works fine. The USB works fine. It looks like it does. We do have a response from the gyro, I expect. Yeah. Oh yeah, I think it's a bit, yeah, the USB is a bit flaky. I'm gonna go and clean that up quickly, and that's easy enough. We just probably give it a tiny bit of heat. So I'm just gonna hold it here. I still have the heat on super high, like on 420, so I'm not gonna stay long, but I want to kind of soften any flux that would be in the USB. Just quickly. Then we come in with some IPA, flood it with IPA, and then our toothbrush. And we try to clean that port up, and hopefully the connections will be solid. There we go. Yes, straight like the MCU is absolutely cracked. It has a small corner missing. And it's not like the cross on the back doesn't explicitly show on the front, on the other side, so that might not be a problem, but yeah, a corner is missing. So yeah, that's why it was getting super hot. That's usually what happens. I could see that it was drawing 3.5 watts, and it was getting crazy hot. So yeah, MCU's dead. So this one, now hopefully we can go back to screen share. It goes fine, it stays fine. Yeah, now it's more solid. All right, so we'll go and do an inspection of the FETs and see if we can see something. Yeah, it sucks that it's actually cracked from the factory. That's insane. Like if it was just like that from the start, that's pretty mad. I've had good luck with those. I have 3 of those in service, and one of which, 2 of them are on 5-inch. One of them is on a Bando basher, and it's been bashed pretty hard and hasn't suffered. So I'm kind of hopeful, crossing my fingers that it doesn't go bad. Right. So nothing obvious. Good thing is now we have a donor for these FETs. Nothing on this, nothing obvious on this face. So look at the other one. Okay. Yeah, nothing obvious. Let's measure. Let us measure. Is that cracked a bit? Yeah, that's just the shell, but it's cracked a bit. Usually that's not a problem though. I mean, we know it's probably not a problem because everything's working. It's probably LDO for one of the parts. Might be LDO for the ESCs, likely, very likely, because it's on the ESC side. And I like how those diodes are always kind of never lay flat, like kind of always a bit to the side on pretty much all boards. That's the Winbond, that's the data flash. So for the logs, we have 3 shunt resistors to measure current, RTVS diode to protect from reverse polarity and over voltage. Weird lines here, not sure what it's for. I think those would be, yeah, those are just caps with a gray sheen. But yeah, let's measure. Let's go zoom out and grab our meter. So first, we'll do the usual. So the checks you always want to do on an ASC, start by checking if something's shorted. So first one, let's go to short continuity mode. I was on continuity mode. So first of all, you check if plus and minus are shorted. Usually they're not, because if they were, something would have melted before you could unplug the battery. I mean, the fact that it's 760, like less than 800 ohms is probably mean there is a problem and something kind of shorted down the line. But then you will check between plus and each pad, and then minus and each pad. And we are looking for open line like this. I'm actually keeping an eye on the resistance, not just expecting a beep, but there's something somewhere that has about 800 ohms of resistance that will tell us what FET is damaged. Okay, let's try the minus. There we go. This guy is, oh, it might be normal actually. Yeah, it might be normal on this board. Yeah, it looks like it is. Some resistance between pad and, yeah, so it must be normal. Yeah, it's just changing. I'm just charging some capacitor somewhere probably. That's why it's kind of changing. It's around 700. Okay, so nothing seems to be shorted. I didn't realize it would have been normal to have about 700 ohms, but that means next step is to test it with motors and see what's happening so we know which motor to start investigating. So the annoying part here, it's not overheating. So the annoying part is I don't have a good test rig for 25.5, so we'll see how we do. Should be okay just shoving it in the middle. Yeah, should be okay. Just shoving it like this. I'll put something under it so I don't so I don't short something. Put some tape. Actually, instead of, I would normally put, yeah, I'll put some Kapton tape. That's the smart thing to do. If I can find my, yeah, I can find my Kapton tape. For those who don't know, this is polyamide tape, which also is called Kapton tape, probably a trade brand. It's very, very thin, very heat resistant. It's the de facto insulator tape for many, many things. And you'll see if you open a LiPo at some point, you'll see there's a bunch of it everywhere because it gives you good insulation without adding much weight, and it's super heat resistant, so it's good stuff. Get some, it's cheap. It's good to have. So straight out, you're saying, Funny, it has its own TVS diode. Yeah, it's very common for both to have their own TVS diode. Most of them will have one, small or big, but most of them will have. So after the ESC breaking, you started using an external one on my advice. And it's external ESC, so I'm guessing you used a stack. So if it was the prod hitting the sand at full throttle, breaking the ESC, yeah, it can happen. That's the kind of thing that can happen. I run mine off a very big TVS array, thinking maybe that's why I haven't burned it yet on the 5-inch, but yeah, I can't say for sure. And it could just be luck of the draw, as with many FPV stuff, FPV electronics, sometimes you get unlucky and stuff burns and you don't really know why. But yeah, that's all I can say, to be honest. I think I'm gonna have to solder a pigtail because this is too close together for me to add I will manage to say what I want to say. Yes, use my alligator clips. So I'll just go under the microscope quickly, clean those pads up. I'll probably clean all of them actually, because I see the wire, instead of desoldering them, you cut the wires. So I'll just tidy those up. Or maybe not, maybe you did desolder, it's just spikes, but these need cleaning up. Let's do that quickly. I'm gonna need this. I'll try to pull the cap legs. Also, this looks like unleaded. Should probably get some leaded solder. Yeah, it looks nasty unleaded. There we go. Might not be though, it's not sure actually. It's shiny here, so maybe it was just oxidized. Could be. Could be. So hopefully this one's just going to be a fat, but recently it's not been fats, it's been other things as well, which can be quite an interesting investigation fix, to be honest. So it's good for my stream, but it means some of the fixes tend to take quite a bit of back and forth, which means a lot of desoldering and resoldering motors. What's this? Okay, let's clean that up. And let's grab some wick. Actually, probably don't need to wick too much, but I'll do some amount of cleaning up, just so we make our job easier down the line. not satisfied with this bit. Okay, let's put some leaded and kind of do nice bolts on those. Put our pigtail on. It's a kind of messy pigtail, but it'll do fine. We're not going for any beauty competition. And let's do motor pads quickly. There we go. All right, let's solder this and see how it sings. Dylan says, you finally took time to fix your drone cable management. It looks much better. Yeah, it's very satisfying when you have it nice and clean. Nice and maintainable too. Yeah, no problem, straight out. You can cut everything. When I receive boards, I'm not expecting people will have prepared them and cleaned them, and that's not really part of the job. I mean, I do appreciate when people do it, but I'm not expecting it by any means. Let's try to solder this and not mess it up too much. Those are smaller pads. Having the board floating like this is not very enjoyable. Let's see if I can do something about that. I can probably grab one of my tweezers and use it as a clamp. Yeah, that will do well enough to get started, I think. Maybe. Yeah, it's going to be good enough. Once again, we're not going for the job of the century. We just want to have the wires connected and not shorted together. Because I keep soldering and desoldering those wires on all the streams, they can tend to have a bunch of stray strands all over. It makes it a bit annoying to work with, but will do. Will make do. Yeah, I'm doing very ugly solder joints, but should be good enough. Trying to kind of pull the wire together, all the strands together, to do my best. Those are not very convenient to solder, at least not on stream, and not mounted badly in a frame. Hopefully I don't have to do it too many times, but the idea is here we'll know which of the motors has a problem, and we'll be able to focus on this, and I can just solder a loose motor on that to confirm it's all working, and we'll only need to assemble it all together at the end to confirm everything spinning at the right RPM, so we don't have like a dead FET or a dead what should we call it, gate resistor, which is a problem that's been happening quite a bit recently. Gate resistors. Oh, damn. Yeah, go here, trying to stop the board going next to the standoff. Well, actually, you're not seeing anything. You can probably lift the camera a bit. There we go. Should be a bit better. Let's go. See my wire, they're all like fluffed out. It's a bit annoying, they're not thin strands. I did order some tiny alligator clips that I was hoping to be able to use for ESCs, but even the tiniest I could find are too big to be securely holding onto ESC pads, unfortunately. So if I want to have a nice way to clamp, to attach the motor to the pads without soldering, and I'm gonna require kind of a custom jig or something. All right, so we're good here. No, no, we don't need to build a harness as we always do because it's an AIO, so that's good. Let's go for 14. I need to grab my cable for the PSU and the adaptator. So we'll go for 4S. We'll put the overcurrent protection on, OCP. That will trigger if we reach 2 amps. And we'll plug it in. All right, so what we're looking for, let me remove the FNAC because we don't need it anymore. We know the board is fine, so it can go away. We'll plug it in. Look. So here we're going to look at the motors tab, and we'll be looking at whether all 4 ESCs respond. So that should become white when I plug it in. Let's go, 3, 2, 1. Nothing's happening. Okay. And it's drawing 4.7 watts. So something's shorted. Okay, I probably could have done this before soldering the motors. I probably should have done this before soldering the motors, but no beep at all means that something cooked in the power regulation on the board. So that means that should be, I don't know if it's going to be easy to track, but it means that we can just remove everything from the board and give it juice, and we can see where it fails. What I want to try though is whether the thing lights up on power alone. Okay, so that lights up. So that means that we have the BECs on the FC side that work fine. So it's the BECs on the ESC side that need cleaning up. So I'll unsolder all this, and we can have a look under the scope and try probing voltages and everything. Max Shaky, you're asking which one should you get first, a microscope or thermal camera? Microscope. Thermal camera is absolutely not essential. It's nice to have, and it helps in a bunch of situations, but you can also do a lot with isopropanol, IPA. You just spray some IPA onto your board and plug it in, and you'll see where it evaporates fast. That's your thermal cam. Yeah, thermal cam is it's a cool tool. It's a very useful tool, but it's absolutely not required. And if you do get a thermal cam eventually, you'll want one of those that have either an adjustable focus or macro lens like mine does, because otherwise you can't really use it to pinpoint components. They don't focus close enough to the board. All right. So the good thing is we do have a kind of working other board that we can use to compare some readings as we go and debug the ESC. That's quite nice. And we'll be able to transplant some parts as well. So, come on, my thing keeps beeping. Okay, so let's go under the microscope. So you got, straight out, you say you got the D-short arming flag. Yeah, that makes sense. The ESC is not even powering up, so you get no motor beeps, nothing. So yeah, that makes complete sense. Hey, Gregory. Okay, that's going on, needs to go back. Let's check under the scope. So let's do a quick tour, a quick analysis. I did remember when I said earlier, no, it's not nice and that's not moving anymore. You said when I said this thing is broken on the side, I mean, it doesn't mean that it's damage here that's causing the issue, but it means it did take a hit, so this could be a culprit. So let's grab my multimeter continuity mode to start with. So how this is laid out is very simple. We have 4 MCUs, here, and here, for the 4 ESCs. They are the brains of the ESCs, the microcontrollers. Those are 4 driver chips. They are responsible for sending the opening and closing current to the FETs to turn them on and off. And here we have the voltage regulation part of this circuitry, and usually you have a fairly high voltage regulator, so something that brings back VBAT to maybe either 10 or 8 volts, or 6.3 sometimes. And then you have another one chained to it, which brings that down to 3.3 volt for the MCUs. The FETs, the drivers, the more voltage you give them to operate the transistors, the more efficient they get. I don't know exactly if they also become like faster, open the things faster or not. But yeah, so I'm guessing one of those is damaged, or one of the parts that it's powering is damaged. And we can see from the traces, we can kind of, we should have, let's put on ground. Well, let's try to figure out what's ground. This should be ground, yeah. This is ground. So nothing's shorted to ground on this one. So this one, so that's the big ground plane. You can see it be here. This should be ground. Okay, nothing's shorted to ground. No, that's ground, but nothing else is shorted to ground. VBAT should be coming in one of those legs. This one. Yeah, no, that was a capacitor charging. So this is VBAT. So one of those two will be the output. I'm guessing this one, because you can see it's fed here into this one. It has a bunch of filtering caps here between ground and it. So I'm guessing this is the output. It gets fed into this. And this is the 3.3 regulator. So what we're going to do is, well, I can show you the non-thermal cam thing, actually. What I'm going to do is put on some IPA, and I'll turn on the PSU, and we'll see what evaporates fast. We're going to see one of those two go super hot. That doesn't mean it's damaged necessarily, but it means either the damage or the thing that it powers is damaged. Because if something's shorted after them, they're going to heat up by trying to give it everything. So let's do this. I'll go for a slightly lower voltage. No need to stress it too much. I'll go for 3S voltage, so like 12.6 volts. And let's flood everything with IPA. And turning it on, 3, 2, 1. So you can see this is getting hot. This is getting hot. Do we have anything else getting hot? Maybe a cap? I don't think anything else getting hot. I mean this, but not necessarily. Nothing else is getting crazy hot. This cap, maybe? Let's see if we have a shorted cap somewhere. Otherwise, we'll measure voltages coming out of those. Still, yeah. Oh. This is shorted. This should not be shorted. So we have a shorted cap here. And let's see what it's... Let's remove this IPA so I can see where it's... What's it between of... So that's between ground. That's ground. And... Okay, why did I tried this, it was... Oh, I missed that this was shorted to ground. So yeah, so that's the output and shorted to ground. So either a cap here is dead or this chip is dead. Do we see the cap page? Oh, I didn't turn it off. This cap is heating up super quick. Can you see? I'll zoom in actually. In this cap. I've turned off the PSU, but we're looking at this cap here. Let's turning on the heat. You can see how it heats up super quick. So I'm getting this is our culprit. Let's remove it and see if we still have the short. So to remove it, I'm gonna go in a direction where I can grab it from the side. It's all very tight, so I don't want to mess it up. I'll grab my favorite tweezers for this. Which are these ones? So as you can see, Mac Shaky, you don't need a thermal cam. I'm not sure what you're saying, Neo. Just see what then coming. Yeah, I'm not sure. I don't understand your sentence. Let's remove this. So I'll keep the same kind of heat. I'm thinking on for 420 and 60% airflow. I'm going to remove this guy. If I can, I'm not going to take, whenever I can, I'm not going to take it from the other
Krhom, there is no sound anymore on YouTube. Yeah. C'est que, en fait, c'est
Oui,
que...
on t'entend sur Discord.
Ouais, et c'est que ton son, en fait. C'est que ton son parce que moi, je me suis entendu moi-même sur YouTube. Et c'était horrible de m'entendre en anglais.
1212 should be back on YouTube. I'm very sorry, guys. The receiver went out of battery. On Discord, do you have the good sound again?
Yes, we have a good sound on Discord
good.
and YouTube.
Very sorry about... Today is the day of technical difficulties. We have overheating camera that's now kind of sorted jankily. We have our... I think thanks, guys, on Discord for telling me. Yep, sorry. So the thing I was talking about, summary of what I was talking about. So we found the thing that's shorted. Yeah, so I was looking into that capacitor that was shorting the thing, but also isn't shorted and is now. So it might be kind of weirdly shorted, but if I go back to continuity mode, okay, this is no longer broken. Let me try giving it some power and see if we can read the correct voltages. And then I put another cap, but this cap isn't strictly needed, so can power without it. And we'll see what happens. So have a look at the watts under the PSU when I turn it on in 3 to 1. And it's still drawing a bunch of watts. So do we now have something shorted? And is it shorted just when it's hot? I don't know. But I'm starting to think this component might be dead. Let's see if we can do the alcohol trick again to see what's getting hot, if it's still the same thing. And turn it on. You can see the fats getting hot too. It might just be normal evaporation from the board being hot after I clean it up. Okay, I think we'll go thermal cam to make sure we have all the information. It is still helpful to have more details since I do have a thermal cam. Let's go for that. We'll do that. Let's go. So here, let's see what's getting hot. We can see the cool spot of the glue. Okay. Oh, can you see it? Can you see this here, the cap? Because the other thing getting hot, could be normal, but the cap here glowing bright, that is not normal. Do we have another cap here that glows bright? Not necessarily. I think it's for the heat of that. So this cap, let's see if it's shorted, the cap on the side. And then we'll pull some brand new caps and put some brand new caps on both sides anyway. But I'm guessing that we're going to have a shorted cap here. Let's see. Why do I keep getting all the wires tangled up for my multimeter and everything? Right, so that was the cap. It is not shorted. They're kind of weird shorted, like 77 ohms. That's probably not normal. What is that what we get here? That could explain why I was getting it beeping earlier. I didn't check the resistance, but my probes will beep when we go under 50 ohms. And if the board is hot like it was before, it would do that. So let's remove it. It was getting hot. It needs to be removed, likely. A cap shouldn't get hot like that. Where was I? Here. Let's remove that and see if we get a kind of high resistance value again. Where are my tweezers now? Did I manage to lose my tweezers, my good tweezers? Here. And the thermal cam. Let's go. Try to not melt the plug. Try to orient my hot air such a way that I don't heat up the plug too much. Okay. Remove the guy. Let's see what we measure. Yes, now we are measuring open line, so it's not shorted anymore. Let's give it juice and see how many watts we draw. Have a good one, Sterilite. See you later. So let's give it juice and see. I might need to. I'll cool off the board for a second. I'm still using my blower, just so that the board isn't crazy hot. All right, let's watch the watts. Okay, that's a normal, that's normal. Okay, so I'm gonna check 1 watt, seems perfectly normal. Let's check voltages. So I'll go into voltage mode. And what we're gonna do is we should have some voltage here, and then the output here should be this, like probably one of those two. So we'll check. So I'll put my black probe onto the ground pad and power it on. I'll put this on the ground pad off screen, and then here we should have a healthy voltage. So something like, yeah, 11 volts. That sounds reasonable. What about here? We should have 3.3 somewhere, so not here. Here, 3.3. And I'm guessing now we're gonna have beeps on the motors. So let's actually check. We don't need to check whether we have beep on the motors, but we can check without moving if we get errors in the D-shot signals. So I'm gonna have to remove this so I can plug the USB. We have our thing. I'm gonna go anyway to the, so it's all beeping correctly. So I'll go to the screen share, and what we're looking for this time is here for this to become white. Let's go 3, 2, 1. So that's doing the beeps, and then it goes white. So that's fixed. That's by being powered up. I have no reason to believe the motors won't turn normally, but yeah, I'll put some caps back and we might be fixed. We should probably be fixed, but we'll still test that the motors all spin correctly at the right RPM. Let's get some, let's see if we can measure off the other board the values for those caps actually. So we have this other board, and as always explain, measuring capacitor values in circuit is usually doesn't work very well, but sometimes it does. So I'm gonna give it a go and see if we get a value that looks like a normal cap value. So I'll go to capacitance mode, and let's start with this guy. And here, because it's on the board, I can stay on this forever and can wait for the measurement to happen. Waiting, waiting, waiting. Maybe one day. Could be that we won't get a measure because it's in circuit. If we don't, oh, okay. So 300, 400, 500 MF or not. Yeah, probably not readable. So what I could do is remove it and measure it off circuit, but I'll see what happens here. If I can measure this guy, I'll just, I mean, those are filtering capacitors. It's pretty much the bigger the better to some extent. So I'll just grab what I have and I'll just put it on there and it's going to work fine. You're getting the same kind of value and then it goes away. It's just weird. So I'm guessing they're going to be similar values. I'll get whatever big cap I have on that size. I think I do have that size. Is it 805? Or is it smaller? Oh, it's definitely smaller. So it's going to be 603, probably. 603. Looking for 603, please. 603 capacitors. And I have 22 microfarad at the biggest. Is this the right size? That's also not the right size. Okay, it is. Okay, it's 0402 then. I guess it's 0402. I'm still very bad at knowing what size caps they are. But it looks like it is 0402, so let's grab some 0402 caps. 0402 resistors, 0402 caps, 50 volt, that's the small values. 0402 caps, where are you? 0402 caps. And we'll use the maximum value we have, which is 4.7 microfarads. And it'll do just fine. So yeah, that's the right size. And all right, so let's put on the actual board we want to fix. And let's put it in the right orientation. That's going to save me time. And let's do them one by one. So we want to do this guy. We want to have some, I'll put on some leaded solder quickly on both. So I need to grab a smaller tip. This should do. We want to add some. So putting some leaded on it will help the solder melt with the hot air, so I don't have to stay as long on the hot air. Oh, there's a big ground plane somewhere. It's sticky. Okay. And let's do the other one, prep the other one. Very good. Did I put some on both pads? Yes, I think I did. I'm not 100% sure. I managed to get enough on the other pad actually. It's the ground one. Yeah, I did get some, so it will melt. It's fine. It'll melt when I heat it up with the hot air. Let's clean that up. Take my sponges. Hello, son. We are fixing AIOs today. And this one had cap issues. Right, now let's put some flux. You're still good on audio, yeah. Grab our new cap. Where's my tweezers? Here. I'll try to not send them flying to the moon. There we go. And now we put it back on. I think. No, it's not. I was going to tack it on and then finish soldering it, but I could not. Yeah, the ground side hasn't melted yet. I think it's good. Yeah, I think it's good. Waiting for it to solidify, and we're good. Let's do the other side. Yeah, I could see the other thing was melted, so I'm pretty sure it's all good. And the other one not. So here, this one's a bit tighter, but shouldn't be too hard. Now we're gonna put some flux on. Oh shit, I'm gonna put some flux on my t-shirt. Ah, sticky. It's so sticky. Flux, we said. Then cap from the reel. Where's our cap here? Nice and quick melt on this one. All right. Now let's put it back together and see if we can spin some motors. We'll do a sanity check that we still have our open line. There's a massive insect tray to get in on my window, like a moth that's about 3 centimeters long. Crazy. Yeah, so that's high resistant and going up. The board is hot. And this is open line. All right, should be all good. We'll still cool down the board and plug it in and make sure it's drawing a normal amount of amps. Right, that's cooled down to some extent. Let's plug it in. So we're looking at the amp draw on the yellow number, and we're getting the normal 1 amp, 1 watt. So that's all good. We can now wire the motors. and see how it goes. All right, it's already all a mess here. Let's put some stuff back. Put my caps back in their little pocket. Okay, that's not the good one, that's the good one. And now we have fun soldering this back again. What direction? Yeah, like this. I have a much smaller tip now, maybe it will help. But yeah. I wish I could fast forward this for you guys, but it's not something that can be done. Can I get some good contact on the tip of my iron? So my tip of my iron is a bit kind of slimy, rusty, and solder's not sticking as well as it could. So it makes melting stuff from above a bit more annoying. But if I put some solder on my tip to get it started, it should help. There we go. I need to buy the right tip. I need to get a good bevel tip would be great for this. But I don't have a bevel tip of the right size, unfortunately. Can I use, do you have a more appropriate, I do have a tip of bevel tip. That's nice, but it's just rusted to hell. And I haven't been able to save it. I'll try it now, anyway. That would make my job easier. But I think it's a bit meh. Yeah, that's this guy here. We'll see how it goes. Does it help or does it not? That is the question. Yeah, I need to make myself some kind of adapter plate, so it's not that annoying to work on. And if I tend to work on 25 by 25 stuff more, I'm gonna have to make something. Good enough. Actually, this might, oh, it should be too short. It's gonna work. It's gonna work. This isn't a bad solution. I shove the this hole onto the screw here, and it's kind of working. Now those I don't think will reach. Oh, this one will. Yeah, that's not too bad. That is not too bad, actually. All right. I don't even need all the insulation. Oh yeah, I do here because this. Okay. Now it should be good. Trying to double check there's nothing kind of fused together. Oh, this one isn't soldered. If I have a motor that doesn't spin right, I'll double check my soldering because Yeah, that's all wicked as fuck. All right, we got it, I think. Let's see. Let's go back to 4S voltage, actually. $16.8. And plug in. Let's see. 3, 2, 1. Do we have the song? Do we have the lights? We get all of them, all the things. Let's see if it all spins, and let's watch out for the RPM it's spinning at. Let's go here and motor stab, and we'll go. Oh, my fingers are sticky because of the flux. Let's go here. It's all sounding healthy. 6.4, 6.4, 6.4, 6.4. Yeah, we're all good. We are all repaired. Victory. This one's good. So this one can go on a quad. That's good. That's nice. That's fun. Always happy when that happens. So yeah, 2 small caps that probably cost 0.03 pence or cents, or whichever your local minor currency is. Yeah, so that would have gone to the bin for less than a cent. And this is why I enjoy repairing so much. We hate when stuff dies for no reason. So yeah, it's apparent, like I can't think of any situation where this would have happened due to user error. So that is 100%, I would say, a QC or component quality issue, and which sucks, which kind of tracks for SpeedyBee. And they produce a lot of things, and the quality tends to degrade over time. So it's a bit par for the course. 2 shorted caps or 1 shorted cap, probably only one. The first one I removed probably was fine, and I was getting beeps because of the second. It was still getting hot, so yeah, I actually, and both failed, not completely. They failed with somewhat high resistance, not completely shorted. So weird indeed. So it sounds like a component quality issue, no more than anything else. But their board designs, SpeedyBee, their board designs are actually super nice. Like the way the boards are laid out is actually super nice. I can give you a quick tour of what I mean. So if we go to the microscope, and so basically you have to use the smallest components possible because they're trying to cram 40 amps of AIO in a small board. So they don't really have a choice. So they're using that small BGA chip that we talked about. But that's the also one of the chips that usually huge is the OSD chip over here, and that's the one with all the legs usually. It's usually huge, but there's a small version. This is because they want to have Bluetooth on their board, they're even dedicating some of the board to ESP chip. The antenna that looks like a UFL is actually a very small UFL. It's much smaller than normal UFL. So they have all that RF front end that they managed to cram in there. And oops, oh, glue, nice glue. But yeah, there's so that's kind of the core flight controller board. It has the gyro, the MCU, the crystal for the gyro. This is the boot button, but it's lost its top. So yeah, I guess nobody's going to be pressing that anytime soon. There's the LDO for that's likely the LDO for this. So the voltage regulator for the ICM gyro. Then we have some BEC, that's the 5-volt BEC chip, BEC coil. That's probably a 3.3 regulator for the MCU itself. Some protection diodes for the USB, and that's all the FC basically. In that small package is all the flight controller, including Bluetooth. And they managed to do all the, so that's part of the ESC, just the FETs here, but everything ESC is on the other side. And that's the thing we looked at before, so the MCUs, the driver chips, the power regulation for the ESC, and what's this? That's a 3.3 volt regulator. I'm not sure what it's powering. Possibly, yeah, I'm not sure. I'm not sure what this one is powering. Maybe the LEDs? No, it's next to, yeah, no, maybe it's not a regulator, maybe it's something else. But yeah. Yeah, it's pretty neat board, it's well organized. It's all, everything's in a row and everything. Yeah, I really like the designs they use. But if the components are shit, and you get dead board. This goes into the box. The box isn't here, it's downstairs. It went with me to the session last weekend. So that's gonna stay here for now. Right, so took an hour and a half for this one. Maybe we can fix one of the two, those two, or maybe actually I'll leave those for next time as the first investigation. And we're not doing all AIOs tonight. The reason is we have someone in the group who's just starting and wants to build their first bundle build. And one of the things that's nice with my repairs is my friends get to fly for cheap on cheap components. That means that I want to make sure they have a cheap stack repaired, and all the flight controllers have disappeared magically this weekend. People have taken them. So I'm gonna see if I can repair a flight controller for them so they can build their thing. And for that, I'm gonna pull the flight controller box. And we are running kind of low on flight controllers to repair, especially 30 by 30. There are 3 of them. So a bunch of 2020, but 30-30, we only have 3 of them. So I'll start with the fancy Goku, because I repaired a fair few of those recently, so I should be easy enough to find out what's wrong with it. I have no idea, but what I'm gonna do is start with a visual inspection. So that's, yeah, there's a bunch of people in the group that fly those, so I tend to have a bunch of them and repair a bunch of them. There was a very interesting one I did. Was it on stream? Yeah, I think it was last week on stream, or was it on my own time? It might have been on my, I don't remember, but there was like a bridge divider for the ADC dead, and then there was a bunch of caps and stuff dead or other places, and took a while to figure out, but got it fixed. So let's see what this one has. Let's have a look under the scope. Actually, let's first remove the gummies, because they are going to be annoying. There we go. To the microscope. All right. What can we see? You guys see? Yeah, you guys can see. It's a bit dirty, but nothing that a bit of brushing can't get rid of. Let's have a quick clean up. Okay. Don't see anything specific here. It could very well be a dead MCU, but nothing we will be able to see here. See the other side. You can see some dirt. This board has flown, but is it anything to worry about? Not necessarily. Let's see if I can actually clean it. Kind of try to get the gunk out and onto the paper instead of spreading it around. I mean, that dirt is probably more water soluble than anything else, so we'll only get so far with alcohol, but oh well, let's not waste too much time. Let's see with the tweezers. Yeah, dirt. So, anything visible here? There's a small bowl here. That doesn't look conductive, so it's probably not a problem. Not sure what that is. Some kind of sand. Looks a bit like seeds, but it's not seeds. I'm guessing it's going to be some kind of rock, small rock. Just general dirt. For once, this one hasn't spent a lot of time underwater, like some of the recent ones I've had. Yeah, I can't see anything critical, anything specific. Let's do a few cap checks while we're here. See if we get a shorted cap somewhere, you know, as a first line of questioning. If I can get my probes detangled. So that's the BEX. I think this is the 5-1 10 volt. Yeah. Just a very quick check. Okay, we'll check if ground is shorted to one of the rails. 0.5, 5 volts. That's 5 volts. Yeah. Yeah, nothing's shorted here. Check the other side, and then we'll plug it into USB and see what's what. Will it be that it's just the same as the two other boards, that the current sensing is dead? I'll do a quick check for that, actually. Nothing shorted here. Nothing shorted here. So the issue that has happened last two boards I've looked at, the current sense wasn't correct. And the way the current sensing works, the ADC that displays the voltage in your OSD and everything, is because the MCU has a leg. I think it's this one or this one of those two. And I can tell you actually which one it is, because I know the circuit by now. Is it this? Oh, this. Huh. Might explain why it's an issue. Maybe the MCU is dead. But that should still beep though. Because that's about... Huh. What's happening here? Okay, this is that. Oh, there might be some kind of gunk that's stopping my probes getting good contact. Oh, it's this one. I didn't remember it was so far out, but yeah, this one. So this leg here is the leg that will read the voltage. But because the MCU only supports up to 3.3 volts and the battery can be up to 6S, you need a way to reduce the voltage, but in proportion to the input voltage. So if we have 16 volts here, we'll want something like 2 volts here. And if we have 8 volt here, you want 1 volt here. And the way you do this is with a voltage divider. And that you do this by having two resistances. So this is connected to VBAT. This is VBAT. This is connected together. And this is connected to ground. And the point in the middle here is connected to the leg. And because this resistor is supposed to be 10K, this resistor is 1K, the voltage here is going to be equal to 1K over 1K plus 10K times VBAT, so about an 11th of VBAT. So the voltage, if we have 16 volts here on the leg, we're going to have 16 volts divided by 11. And if you go and look at your MCU and go to the battery tab, in Betaflight and look at the voltage multiplier, it's going to be like in the calibration tab, it's going to say 110, and 110 is that 11 ratio. So the more you know. So let's see in resistance mode if we get good values here. I'm just ballpark. So this should be 1K, and it is 1K, and this should be 10K, and it is 10K ish, or is it only 10K ish? No, it is 10K. It's just charging some capacitor somewhere. It's going up, but it is 10K. Okay, so those are probably fine. All right, let's see if we can, what we get on the PC. I'll grab the FNIRSI again, so we don't roast my PC. And let's then grab the extremely long cable again. And let's see what we get. So we are looking at the amps here, or the watts, related. Okay, we get 0.8 watts, which sounds perfectly normal. We get the blinking lights. So that's probably going to be good. Let's go to the screen share, see if we can communicate. And we can. And we do. Let's see if we have a gyro. Looks like we do. So what's wrong with this? I'm guessing a back, probably. So we're going to have to see if it powers up from BBAT. Because otherwise it looks good. We'll see also if the voltage divider works. But let's go and check if it powers up from BBAT. Can remove the FNIRSI. FNIRSI. Yep. It could be that the board is perfectly fine. As you might know, if you're a regular here, very often people give me stuff that actually works perfectly fine. So yeah, that can happen. Oh, I'm started to see what might have happened. So let me show you what I just saw. So I saw this burnt mark here. And this with the dirt here makes me think this was above an ESC that burned. And that would explain why it's perfectly fine, possibly, we'll check. But it's very common when people get fire in their quad, they just toss the stack and they give it to me, where the FC is actually perfectly fine. So there is a very high possibility, because this burn mark here, it doesn't seem to be here, like inside the plug is fine. So I don't think there's a short due to the connector itself. I think it must have something that burned next to it. So yeah, let's give it some juice and see if it starts. So we'll have this plug, and it is the right plug for once. So we'll plug it in this. We'll double check that no pin is bent, but no pin is bent. Right, put that. And we'll see if it powers up. Still have OCP, so if it was more 2 amps, it will turn off. So it is a back issue. So if we have a look here, I'll show you under the scope, probably is better. Let's go to the scope. It is a back issue, so yeah, that makes sense. So let's have a look at the LEDs and see what rails light up and what don't. But it looks like 3.3 isn't. Okay, 10 volt, 5 volts is not lighting up. We know that 3.3 works because it works when we use USB. And we know because we can connect to it. 3.3 powers the MCU. So if we have, here we are going to have 5 and 3.3. But 5 is probably not going to light up because 5 the light is from the back and not from the USB. So yeah, 3.3 here. So it's the 5-volt back that's dead. Let's figure out why. So, easy enough. Hopefully you can find the donor, if it's the chip, and because the AMG chip always struggle to find donors. I think that's the 5-volt back, we'll check. So I'll go back to continuity mode, and on those, so I learned recently that those coils, they are part of the back circuitry, and when it's a back, that's called buck converter. That means it takes high voltage into low voltage. The coil is always at the output of the circuit, so I can test which of this output matches 5-volt or 10-volt pads. If it's a buck boost converter, which means it can actually either lower or bring the voltage higher, which is common on AIOs for whoops that can take 1S, sometimes 2S, then the output isn't on the coil and you can't just check the coil. But here, we want to see which one is the 5-volt back. So I'm going to put a probe on 5 volts here. We'll see if it's this one. It is, and this is the 10-volt back. We can confirm by putting a thing on 10 volts, which is here, 10 volt. And we'll check here, and it beeps. So yeah, this is a 5-volt back. I wonder, so the issue I had last time on the last one, the 5-volt back wouldn't turn on because the enable pin wasn't connected. And this enable pin is one of the pins on the side, I think that's this one, is pulled to VBAT through this resistor, which is supposed to be a 470K. And this should be connected to VBAT, I think. No? Huh. Shouldn't it? Wasn't it the case last time? I thought it was VBAT. Okay, maybe I'm mistaken. This was supposed to be... let's go to resistance mode, see if we can measure this resistor. Okay. Maybe it was this one and it was the 10-volt back I was looking at last time. Don't know. Let's go back to continuity, and it could be is this one pulled to VBAT? VBAT. No, I might be misremembering the circuitry. Okay, so this thing is not powering on. Now we'll check if we get some shorted caps around, which I did check earlier, but now it could be that it's not getting power through the diodes. So let's check the diodes. We'll see this one. Yeah, it's good. Huh. Oh, not 0.62, no, that's good still. That's two different Schottky diodes. Like this one has a very low voltage drop, so not 0.18. This one has a bit of a higher voltage drop, not 0.62. Maybe still it's a Schottky, I don't know. All right, so let's have a look at what kind of voltage stuff we have on this. And then I'll go and double check the data sheet on this guy, actually. Let's go do that. And I think I bookmarked it. I might have bookmarked it. Let me show. Let's see. I should really bookmark all my... No, I haven't bookmarked it. I'm going to do a quick search quickly. Hold tight. I need to remember what it's called. And I don't want to show you all my web search history, so I'll do this quickly. I have it somewhere on Gemini. the best way I found to identify ICs is to start asking Gemini or some AI. It's not, sometimes it struggles to find them, but for some of those ICs, it's actually quite good. But this time it didn't, so it's bad. What I can do is find my listing from AliExpress when I bought some fake one. I'll do that. Because I did buy some spares of this circuit, and it turns out they were fakes. They were all continuous on all pads, meaning it's pretty bad. It was basically worth it to make a fake of $1 part, which, yeah, I don't think it would have cost them much because they basically put a slab of metal inside the package. So it's probably cheap, but sorry, I'm having technical difficulties today trying to, nothing's logged. I'm gonna have to hold, we'll do some reading of it very quickly, but I'm gonna have to go on my main PC for a second to go and fetch that datasheet. Hold on for a second. I'm not logged into all the websites on this streaming laptop, so it's a bit annoying. And I want to find the name of the chip. And it's called MP9943. MP9943. And now I can probably bring you onto the PC. And so we'll want all datasheet. It's nice to find some datasheets. MP9943. And it's an MPS, and I think that's the GQ. And we'll get the data sheet. Please give me data sheet. Give data sheet. Did it give me? Where's the download? Bloody download! Oh, I need to enter that stupid code. Okay, and this should be the right thing. Let's see from the description. Part number, top marking. Yeah, top marking here is AMG, and that's the chip. So now we have the chip, and we know the enable here should be pull height, so it's the third pin on the left. So let's see if we get that. So we'll go to voltage mode. We need to plug it in. Let's plug it in. So I've plugged this in, and here. So from what we see from the data sheet, the VCC is the second pin, the enable is just below, and the where's the output? Here. Where's the output? Power grid is top right, FB. The output is SW. SW is third from the right. So let me show you in this. So we should have here. So those are very hard to see pins, but this should be VBAT. And we can see, well, let's let's power it up. So I'll check, but this should be VBAT, so we should be getting 16 volts. This is enabled, so we should also get 16 volts, which kickstarts the chip into working. And the output is the third pin here, but you can just check here on the coil. So let's turn it on. And ground VBAT, we should be getting 16 volts. Here, we should be getting, we're not getting anything. Huh, why are we getting 4.8 volts between, between ground and 4.8 volts? And that's getting 5.1. And the output is, 1.8. So something weird is happening here. That's supposed to be VBAT. So do we have, maybe this is a diode. So that's on ground. Is this VBAT? And this is supposed to bring VBAT. It does. Is this VBAT? This is VBAT. But this is not VBAT. This is supposed to be VBAT. So that resistor is dead as it was before. And so I think we need to turn this resistor. Yeah, that looks like it is. So here and here, not VBAT. And that, if I remember correctly, so the reason I wasn't getting a beep. Let me explain to you the circuit, but basically the current comes in from VBAT here, goes into this diode here, and then outputs with a voltage drop of 0.2 here, and then goes here, and this powers the enable switch here. Does it power this as well? No. I don't know why where this comes in, that should be, is this continuous to this as well? Huh. I don't know what that VBAT goes to, because that also should be VBAT. So there's something else going on here. Another resistance that's dead, maybe a 0 ohm. Okay. Is this VBAT? Okay, so this is supposed to get VBAT. Is that coming through? What is this resistance supposed to go? So let's have a look at the typical diagram. So that's pin 3. Something that you can learn a lot from looking at the data sheets. So here, so this is the part I was probing, and it's supposed to be connected. We see there is a resistance that's connected to it. And if we want to understand why, we can check the datasheet for the diagram of how you make this chip work. It's going to be somewhere. It's going to be typical application. It should be, maybe it might have been at the start actually. Typical application. And typical application, that's here. So here, so as you can see, we're supposed to get enable sync direct. We can get directly from we usually, and you can read it in the datasheet, it explained, but usually you can just get that through from VBAT through a high resistance resistor. But for VN, they're not showing any kind of resistor. So what's maybe happening is that they're feeding in 10 volt from the 10 volt back into VN. I doubt it, but we can try to understand it. Hey, Fiat Motions. You were wondering if I can repair. I don't repair stuff for people, just so you know. But the Flywoo ESC that's imploded to the current sensor, that's very unlikely. current sensor doesn't implode anything. And also you're in Texas and I'm in France, so that's going to make things very difficult. But I can possibly help you diagnose it and see if you can get it fixed or fix it yourself. But yeah, basically the way I work is people give me their hardware, my friends around me give me their hardware, and I repair it or don't, depending on whether I have the time or want to do it or feel like doing it. Put it into a box, and when people meet me in real life, in a session or anything, they can pick stuff, they can grab stuff from the box for €5 each, but I don't really do repair to order regardless, I'm way too far away from you for it to be even remotely viable. So yeah. Oh, you were talking about Texas Instruments. Oh, which is Texas? I read in Texas. Yeah, but yeah, but if you, so yeah, if you want my help, I very down the current sensor will be the thing that's most, or at least I've never seen that before. Yeah, I don't really know what it could be. There's many possibilities. You need to analyze it, but it's funny. Anyone who wants to grab stuff from the box, people who grab stuff from the box must have given me some electronics in the past. That's once you give them in something, then you're in the club and you can grab stuff from the box. But until then, the box is close to you. All right, so I'll see if I can track down where that VN goes to. It should be, I mean, I'm just gonna get the stuff to beep until I figure it out. But I'm pretty sure we need to replace that resistor. So we're still in continuity mode. And so our VBAT goes here, we said. Oh, and this, what's the resistance on this? Does it have a resistance? Because I would, yeah, okay. 80K? Rising. So it's a shame I don't have any donor. I don't think, do I have a donor on this? No. I don't have any reference to look up, but let's see what's the other side of this resistance. But I can't, is that not ground, not bad, 10 volts, nope. Nope. Nothing. A pad on the, I'm guessing it's going to be this pad then. Oh, it's power good? No? Weird. What the hell is happening to this? Where is this supposed to be connected to? It's supposed to come from, no, it's not coming from a 10 volt, I wouldn't think. There's no other good. Okay, I'll start by changing this resistor and see what it says. And because, I mean, could be that the chip is bad. If the chip is bad, it would be pulling stuff. Okay, I'll remove the chip first because it's the easiest thing to put back. I'll remove the chip and see if I get, that's not the right chip. This is the chip. I'll see if I get a good reading on the actually, I really want to understand how VBAT, so this, no, not, I hate not understanding, so we have VBAT that comes to this guy, okay. Where does this one come from? Okay, so that's ground. So that's a protection reverse current diode. Okay, that's like a TVS. So this one you can ignore. I know this because it has its, so the current flows from left to right here because of that band here. And the butt is on ground, so it will only conduct if there's high voltage on ground. So that's a voltage protection diode. So this comes from VBAT. This goes here and it's supposed to bring VBAT here, but I'm surprised it's not also connected to enable to the VBAT pin here. Yeah, so I don't know where this could be connected if it's not connected to directly from here. Where could it be connected to? Yeah, we know it's connected to this. Then this is going to be ground. Yeah. So yeah, I'm guessing this is supposed to be a fuse then. But where's the output? Where's the output? Because this is not connected to this, unfortunately. So I don't know. I don't know for sure, but this seems to have, doesn't seem to have bad resistance. It does seem to have a bit of, oh, it's lowering. It's supposed to be a 570K from what I remember. Let's see if we get some heat somewhere, actually. Let's see if we get some heat somewhere in those components. I'm guessing we don't, but it's only, well, if you'll send stuff, that would be much appreciated. You should break some more 30 by 30 flight controllers because I need more of them. But yeah, then you'll be able to pick stuff from the box. Can we see anything? Nope. Nothing's getting hot. We have tried to understand it for long enough. I'm very confused at where this is supposed to get its feedback, but what we'll do is after I remove it, we'll probe the voltages on the pad, see if we get sensible values. Okay. Let's keep that chip around just in case it's perfectly fine. Now, I'm going to cool the board down. resistor values can be completely off track if when the resistors are hot. So let's see what we read here now. Oh yeah, 1 mega ohm. I mean, in and of itself, it's not necessarily a problem that it's 1 mega ohm, but I think it's about to be 470K if I remember correctly. So let's plug, so I'll give it some juice. And measure voltages. Back to voltage mode. Okay. Put this on ground. And here we should be getting, yeah, we're getting 15 volts. So we are getting VBAT. And here we are not getting VBAT. Are we getting VBAT here? No. No. Is it internally burnt some way? So this isn't supposed, is this supposed to be? So, yeah, so those aren't, this is getting 15.2. Okay, so this resistor definitely is having an issue because it should be, because there's 16.7 volts here. If it was a good resistor and there wasn't any current leak or anything, this should be also at 16. It's at 15, so some current is passing through somehow. And yeah, I'm not sure what could be the resistance in between this and this. So let's see if we can measure some. Maybe we also have like one of those capacitors that are kind of half shorted. It could be leaking current. So that's just going up and up. That means it's just charging the capacitor. Likely, maybe not. That's not supposed to stay like that. So if we go to the good back and we check the equivalent cap here, it does kind of the same thing, doesn't it? Yeah, so I'm not sure. What we can check though is on the other back, similar things. So here, what do we have? Let's check voltages on this. So let's turn it on. I mean, we're lucky that we have two backs, so we can check stuff. So that's the enable pin. Not in voltage mode. Let's go to voltage mode. DC volts. Ground. And here we should be getting, we're only getting 5 volts, and this is getting 5. Okay. What? This is weird. Where is that 5 coming from? 16 and 5. Weird. That's not what I had last time. I don't know. I don't understand where this is coming from. Where's the 5 volt coming from? That's very confusing. That is very confusing. So is the 10 volt working fine, or is the 10 volt kind of not working either? It's just enough to have an output. It's showing 10 volts. All right, let's replace the chip and see if we get something. But the fact that we're not getting 5 volts on the supply pin is a problem, actually. So I don't know. I'm very lost. We could just put an external back, just to be clear. We can just use an external back here, and it's going to work fine. But that's not the plan. We want to repair this. And yeah. Why is that 5 volt coming from, though? Just the resistance? resistor. It must be a voltage divider, actually. I think it has to be a voltage divider. We can check by me changing the voltage. So here we have 4.8 at 16 volts. What do we get at 12 volts? So let's give it 12 volts. And ground. And 3.4, so it is the voltage divider. And here it's still a 4.8 though. And how's power good? Is my diagram not? No, power good is 4.8 too. Where is the 4.8 coming from? Where is the 4.8 coming from? Okay, let's turn it off and try to continue understanding. Yeah, it's sometimes you just don't know and you have to spend the time trying to understand the circuit, because this is not exactly the same as the typical diagram on the data sheet. So here I'm guessing it's going to be continuous to this, like the other one, and this is not continuous to V, but is it continuous to the output of this? No. So this is where, well, let's actually check the voltage. Let's try to trace it. So ground. So we know this is supposed, that's our 4.8. This will be 4.8. If I can probe it. Yeah, and this is also 4.8. So that's supposed, I'm guessing that's supposed to be a fuse. And is this 4.8? It's not. Okay. Is this coming from power good? No. Where is 4.8? Where do we have 4.8 elsewhere? Oh, 5 volt pad. It's not 4.8 for sure. Where is this 4.8 coming from? The other side? Where is this 4.8 coming from? Has to be, it's not a voltage divider, right? Let's have a look on the other side. Do we have anything that's splitting 4.8? Let's go around here. Shouldn't be, that's the back. That's another, that's probably the MCU 3.3 regulator. So yeah, it's not. Yeah, I have no clue where this 4.5 can be coming from. I'm starting to think the diagram I have for those is not correct. I'm starting to think it's not the right diagram. Yeah. Yep. So because I'm guessing, let's see if we can continuity mode this. Is this continuous to this? Okay, this is continuous to this. So, and this is continuous to this. Yeah, so if that was indeed power good, which is signal high that comes in when the BEC is outputting current and the power current is stable, the power is stable, then why would this be connected to VBAT? That makes no sense. And this, yeah, that would make no sense to be connected to VBAT. So I'm guessing I've been looking at the diagram and the diagram is bad. Hi, ISK stands from other IC. I have no idea what you're talking about. Beetlebass, hey, you flew your drone in a dirty pool, was plugged in water for 20 minutes. Before you got it out, took everything apart, clean, dried, reassemble, and when you try to arm, the short saver set off and killed the power. Would this indicate that only your ESC is damaged? Can't tell. It's not something you can tell just from the thing triggering. What I would do is pull everything apart and test stuff individually. So you plug in the so kind of stuff I'm doing here basically. You plug in your FC into the computer, see if it all works, if you get a gyro, if it gets better flight. Then you give some power to the flight controller in some way, some VBAT, and to see if it lights up. So I'm doing it with that kind of special cable to give it VBAT, but you can make yourself one of those actually. It's probably the simpler way. So this is a wire that has one end has a JST plug to go in the flight controller, and the other end has a XT30 connector. So you can plug in the LiPo basically, put whatever connector you need. And that's where you can test that the flight controller works, that you can read the one of the things that likely to be dead, that happens when stuff spends time in water, is that you won't be able to get the voltage value in your OSD or on the flight controller in Betaflight. This is because, actually I can show you where it shows. So let me plug this in. So I plug it in and go to Betaflight. And connect. So here you can see the voltage here. And when you plug in your battery, it will show the actual current voltage. And this usually dies fairly quickly when your UFC spends time in water. And this is because everything that's on VBAT, so on your electronics, anything that's on VBAT, so there's going to be a bunch of the pins that are on VBAT here, and the side of the resistor that measures the voltage, one of them, and everything that's on VBAT. So it might be also on some of the caps and some of the things on the other side near the backs. That's going to have rusted away. That rust in 20 minutes probably it's likely to be rusted very badly. So if the connection is bad, then you might lose some features, stuff might not work. It's going to be the same on the ESC. So your big pads are going to be rusted away, the plus pad. So yeah, you have to investigate one by one. And in those streams, I'm trying to give you all the advice and the tools to diagnose. As you can see, it's not always simple. So yeah, there's some amount of figuring it out. But basically, anything that's on VBAT might have rusted away and might need fixing or replacing or something like that. Yeah, sometimes I would say like the least likely to have survived is the ESC. The most likely to have survived is anything that never touches VBAT, like your RX, your VTX if it was on a back, if it wasn't directly on VBAT. So if it was on the plug on the board, then it's probably fine. Your RX, your buzzer, all of that should be fine. The motors obviously don't mind at all. Don't mind the bath. But yeah, the thing that might have died is all the power management on the flight controller and ESC, and some other things. All right, so let's have another look at this. How I might have been reading this datasheet badly. But it did seem fairly straightforward. It's top view. Wait, what's in? Is in the power in? There's VN and there's VCC. What the hell is VCC? Maybe I was confused. But power good and VCC, same thing. Yeah, I must have been confused. Yeah, VCC is
VCC is the
photograph.
internal IC power.
Yeah, so that, hey Livia. So yeah, I was looking at VCC and I got confused. So V in, so let's see if we get V in correctly on this pad then. So it's the second pad. Let's have a look at that. So yeah, it makes sense that it's weird that they are both connected together with power grid. VCC is connected to power grid through a resistor. That's a bit weird, but maybe it's normal.
The IC generates some voltage inside, and usually they take it out to decouple it, but probably they use it to feed power good.
Oh yeah, okay. So in is the second. So let's see what we get. We are not in voltage mode. Voltage mode is good. Oh, I need to plug it in back. Plug it back in. Give it some juice. So do we have 11.8? Yeah, so we do get current in here, and we do get some amount of voltage on the enable pin. So it might just have in the chip. I need to find a new chip and transplant it. I'll look for one. I know there are some. I might find some on those boards. Oh, those things.
It's a very common IC. It's used
Yes,
all over.
but I have harvested it a lot. So that's just a pure ESC. That's not an. It's not an AIO. So yeah, I harvested it a lot, so I don't have many left. And I bought, those are the ones I bought once, and they were fakes. So no AMG here. Was this one? No. I think this board doesn't use AMG. It's all dirty and everything. Yeah, it's all conformal coated. This guy, does he use an AMG? AMG chip? No. That's the same one as just checked, right? Okay, I do know well. I'm not sure. Could an RX use one? A VTX use one? Nope. This guy. Nope. Sucks that I don't have many donors for those. Pretty sure I've checked on all my generic, on my flight controllers. Oh, maybe this guy? No. Ah, yes, I do. No, that's not the AMG. Oh, it's another chip. It's a different one. Same brand, different chip. This one, nope. This one.
The stream is stuck on the datasheet.
There's what, sorry? Oh, MG. Those are good. All right, I have a donor. On this big Matek thing for wings. So hopefully it's good. We'll see. Let's pull it out. So how are things with you?
It's funny. I just repaired a Matek FC today. Had both backs there. Same manufacturer, but the ones with inductor inside of it, and they say they are 8S capable, but even on 6S they run like super hot.
Yeah. And was it the chip that died too?
Both of them. I don't know what happened.
So
I
on this
repaired
board
it.
specifically, before I had a case where it wasn't the board that died, it was the resistor that pulled and the enable pin high was dead. That was very first time I've seen this, actually.
Yeah, it's pretty interesting that the resistor died. It meant that a lot of current passed through there.
I'm guessing where the chip must have died. Yeah, that's not very pretty. Let's reflow it. Actually, sorry, I didn't forget to pull the microscope in.
Man, you need to give me the name of the camera you are using for the microscope.
Oh, I find it not that good, but but after tuning the parameters, it's all right. But I'm using a trinocular microscope. I don't know if that's what you have.
Yeah,
And
I use the same. Just the sensor I need to change because mine
yeah,
is quite old.
this is the Mechanic 4K camera. I can give you the reference, but I think there's better for the price. There's a way to find it.
Yeah, there are a lot of people that recommend one that's almost 600 euros or something, which is
Yeah,
quite high, but
no, that's a bit skewed. Skewed. Shit. Okay, let's see how it goes. Let's see how it goes.
but I have to admit it's a fairly stable regulator.
What is?
This regulator is quite good. I mean, didn't died on me.
That's good. I have a board, actually, I can show you. I have a board in my donors. This one here uses the tiniest becks I've ever seen. And those are the becks. And they first LiPo, the 10 volt beck died. And then 20 LiPo later, the 5.1 died. Just, yeah.
I think that one is very similar to what GoPro used on the bones, and also DJI used them, but I might be mistaken.
It might be that DJI uses them better than TuneRC. But yeah, that. So let's see if that powers up. Oh, it does. So it was just the chip. We got the lights. So a lot of looking around trying to understand it, but in the end it was the chip. And now we have, let's see if we have, oh, we did check that we have the voltage reading correct. So I think that's likely to be fixed. Yeah, good. Awesome. There is a second fix for tonight. And it was the AMG chip. So let's toss the other one. It might have tossed itself. I can't find it anymore. But it's nice. I don't think I have anything else I would need to try. So yeah, that's repaired. The boy is good. Yes, what time is it? Well, we still have half an hour of stream. Let's see if we can get a second flight controller. Maybe we'll have a quick one. But yeah, that was a simple back swap. I need to get more opportunities to repair those so I can get better at figuring out the diagnostic, see, oh, when that's pulled to whatever value, then it's probably the thing that's shorted. That's gonna come with time. All right, so let's grab the NFC box again. Let's do a, oh, this one. This one's funny because it's very sad on one side. I'll show you what I mean. So we have the fun side. This is the fun side. And this is the sad side. There's nothing here. There's just a back. Just a back. Do we see anything? I see some damage here, but anything specifically dead? Not here. This has taken a hit, but nothing I would be too worried about. The crystal has taken a hit too. Yeah, nothing I would consider too weird. Before we do anything else, we'll try the plug it into the PC. Let's go grab the FNAC back. Power the FNAC. This can go away. Well, thank you, Hanks. We fixed. It wasn't that tricky. I just took my sweet ass time to try to understand exactly before I started swapping parts. But in the end, it was just a chip to change, so it was fairly easy. But thank you. Thank you. Let's plug this in. See what it does. That would look, I don't know what that board is. Looks a bit like a T-motor. Does it say? Does it say anywhere? Eh, doesn't. Oh, it's not USB-C, it's USB Micro-B. It's an old board, or maybe not, but it's probably an old board. Let's see what happens. And we get nothing. Nothing at all. So it's probably a damage. Oh. Oh, interesting. When I started. Huh. Look at that. I got something, and then I'm going to reflow this chip. You can see it works. Does it work? Does it connect to the PC? It worked and it didn't, and then it worked. Could be just the USB that's dead. That's the kind of, not dead, but okay. So I get it. I feel like it's probably the USB. Yeah, it's probably the USB. Let's clean the USB up. I don't need to reflow the chip. It's probably not reflowing the chip. It's likely to be the USB being dirty. So we don't, it doesn't short, so I can pack that away. Can pack that away. And we can clean up. USB might just be a back as well. Could be. USB, let's give it a bit of heat. And then do the same thing as before. We'll give it a bit of heat and then we'll get some IPA inside and brush it. I don't want to heat it too much. I want to start melting it. And use my high brush count brush. This has a lot of small, tiny brushes. It's really good for those. Right, let's see if we get a better connection. Do we get a better connection? Okay. So we don't get a much better connection. Okay, USB device not recognized. So, but we get a blinking, and blinking usually means it's actually running. So I still feel it's a... Ah, there we go. There we go. Matek, it's a Matek flight controller. Ooh, well, how old is this? It's too old. Too old. Let's see if we can update it. Can it detect? What the hell is this board? Matek something. Let's go and try to... Sporny saying, after screwing all 52 screws in your build, you have the urge to buy an electric screwdriver. Yeah, so you should. Hey 3D, I'm doing your boards next week. I did, so I keeping them fresh next week. I'm gonna start with them. So yeah. Let's see. I mean, maybe it's a Matek, running Matek. Maybe it's not a Betterfly board. I don't know. Let's see if we can find it online. Let's see if we can. So it's an F45. F45, yeah. Let's see if we can find it. Which one is this? What one are we looking for? That's this one, I think. Let me. Yep. Nope. Not true. Not true. That's not this one. Mine has. It looks like a mirrored version of this one. Similar to this one, but not exactly. Kind of flipped and rotated, but and let's see if we can go on Matek's website and find some legacy stuff. I mean, I can randomly try flashing a target and see what it does. It is an F4. Products. Flight controllers. Yeah, that's not. Can I see the old ones? Yeah, that's just not what I discontinued. Maybe we can find it here. Might be able to find it here. Page 103. Hopefully we can find it. No, I accidentally clicked. Fourth. Oh, no, not this guy yet. Not this guy. It does not exist. Yay. Okay, so when I connect it, it does say Matek something. So we'll try flashing it. Yeah, it says I saw it. Where did I see it? Disconnect. Where did I see Matek? I saw Matek somewhere. Maybe I can type status here. Yes. It's an ICM gyro. It's an old ICM gyro. So can I? No. Yes, I should be able to see some information at the top on the target. So it is Betaflight, Matek F45 and 4.1.1. Let's flash it. F45. Which one? Don't know. I mean, it has to be one of them. F45 standard STD? I don't know. We'll try and see how it goes. Let's go for digital. And let's try that. Yes, I want to continue. And we'll see. We'll try targets until we find one that seems to do the beacon lights and move the gyro. Kind of a bit. I mean, that's not that many Matek F4 or 5 targets, so it's bound to be one of them. So while we wait, if you have any questions, I'm here to answer it. Actually, Beetle Bass, sorry I didn't answer how to test your ESC. Hopefully you're still around, or you'll watch this on demand later on replay. Oh, things have finished flashing, but let me give you an answer. How do you test your ESC? VTX gives you video in the goggles, so that's fine. So that's probably that your ESC is fine too if you're getting OSD. And let me see if that's good. So how you test your ESC? The best way to do it is to start by removing everything except the motors. and you plug in your LiPo with the motors through the smoke stopper, obviously. If it triggers, then something shorted, so you are, unless you want to start repairing, which I guess my channel is about, so so you can just watch me repair ESCs and kind of pick up some knowledge there. We can just chat in my Discord. And otherwise, you can just if the motors beep and do the normal thing without anything plugged, so no FC, anything, just the motors and the LiPo, then you can try adding the flight controller again. But I'm guessing since you got it, so it's shorted before, I'm guessing it's just going to short and your ESC would be dead. So next steps are a bit more involved to test more stuff. So let's go to our flight controller, which has flashed and is blinking. So the target isn't completely bad. And is moving. Okay, so that might have been the right target then. So that's working. That's on a fresh beta flight. Let's see if we can power it from a PSU, see if one of the BECs is dead. Maybe that board wasn't damaged, so someone gave it to me because it was too old, beta flight was too old and they weren't flying it anymore. It could be that it's perfectly fine. Let's try it. Back. We have a plug. Is that a 7 count plug? I think it is. And I think I've made one of those recently, but it was in the box. I might have to make another one. So let's go under the microscope and see. That's donor goes back here. Do we get any markings? We do not. And this board does not have any. Oh, it says here bat and ground on the other side. I have one of those kind of plugs, but I'm just going to solder to bat and ground. That's going to be easier. Let me grab a small pigtail. I'm going to put an XT30 on it. That's some high quality soldering here. Good enough. Let's give it the usual 16.8 for its voltage. We still have the OCP going on, so it shouldn't burn. Let's see if it lights up. It does not, so it is a BEC issue. All right, let's have a quick look around the back. 2 BEC issues today. So there's only one BEC, and it's this chip here, and it has a selectable voltage here, I think. Weird. But yeah, I'm guessing that's, let's see what we get in terms of voltage out. DC volt, we're still in DC volts. Ground here. So we should be getting VBAT here. 10 volt only. Huh. Is that not VBAT? Oh, so that's the TVS diode. Where's the connector here? So we're getting minus 10 volts. So we are getting 10 volts. So this thing is working. That's the 10 volt back. So are we not using a back for the other side? Let's see. Let's have a look on the other side. Is it not a back? Just LDOs? Could be that it's just LDOs. Okay, that's an LDO. There's some gunk. LDOs are voltage regulators, but I don't, unlike BECs, they don't do kind of clever voltage management to get the right voltage. They kind of dump all the voltage that drop down as heat. So are very inefficient, but they are produce clean power. So I want to get rid of this stupid goo. So the damage on the oscillator isn't an issue. So what's this? Is that the gyro? Yeah, I'm guessing that's the gyro. It's not a gyro I've ever seen. So yeah, I'm guessing we're gonna see 10 volts coming in this thing. Let's see. Let's see what kind of voltage we see. Do we have a ground pad somewhere? Ground pad here. Guessing we don't have 5 volts here. We do not. And 0 volts. Yeah, you get nothing. Okay, so that must be the 3.3 volt for the MCU, and that works because we know when we plug USB, we get voltage here. So let's see on the other side. Let's go back. What do we have here? We have another regulator here. That might be ground. Yeah. What do we get on those legs? Ground. Nothing. Nothing. And nothing. Okay. So we do get 10 volt output. We do get 10 volt output. So I'm a bit lost as to where this goes. Where do the 10 volts go? It's weird to only have one buck converter. Curious. We have to be getting 10 volts somewhere here. I'm guessing, let me grab ground. I'm guessing on some side of a resistor somewhere. And nope. 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 We're getting 10 volts probably. Somewhere. Yeah, this is a weird flight controller. It's not up to the same usual standards I'm used to. So I have to track it down with a bunch of beeps all over. Continuity checks. Nope. Nope. It's funny because it feels like it should be on the other side, but there's nothing on the other side. Like, virtually nothing on this side. I'm guessing I'm gonna have to look up it's possible that this is a back that generates both 5 and 10. And so those two legs are good. That's the output. And it's the 13 volts. What? What the hell is 13 volts here? Nothing, ground, and... Yeah, I guess maybe this is supposed to generate 5 volts on this leg. It's not. Let's see if we can get continuity between this and 5 volts. Turn it off. Continuity mode. Is this supposed to be 5 volts? Well, not directly, at least. Okay, so this comes here, and this goes where? Where does this go? Isn't that ground? So this goes to ground. So this pulls this to ground. So it's a pull down. Why does it have a pull down though? 700 ohm pull down. I don't know. I don't know. I do not know. Does it feed into any of the other ones? No. Yeah, I don't know. I'm gonna have to look up the chips and try to understand a bit better how it's made. But we are out of time for today, so this one's gonna be, could be made to work now with an external back, likely. But I like to fix it if I can, so I'll try to understand how it works. But I'll look up the parts, see if I can understand them better. All right. So today was a decent fixing day. So we fixed an AIO with a couple of capacitors that needed changing, and fixed the back on a Flywoo Goku board that's likely going to go into a beginner's build. A friend who's starting up in the group, and he's going to be able to fly for cheap, build a Bando Basha build for cheap, and that's always good. Anything else I wanted to say? Yes, as always, if you're still around and you haven't clicked the like button on the stream, that would help a ton. If you were happy to do that for me, that would be nice. Otherwise, next week we'll be starting off with the Newbie Drone AIOs, and we'll see if we can fix 1 or 2 of them. That's going to be fun because they are very interesting board with a bunch of weird decisions on them. And after that, we'll see. But yeah, thank you very much, everyone, for coming to the stream, being around, keeping me company as I repair stuff for the crew. And obviously, thanks again to everyone who is sending me boards. That is very much appreciated. It makes for good content, and it's, yeah, super nice way to contribute to the stream. So yeah, have a good one, everyone, and I will see you next week. Bye.